your own AI. We'll explore.
Hi, everyone. This is episode number next of Near Office Hours. Today we have Arto from ASIMOV Protocol. Many people in Near ecosystem have known Arto since his work at Aurora. Arto, do you want to say a couple of words about yourself and a quick introduction into what ASIMOV Protocol is doing?
Sure. So, Alex, nice to see you. It's been a few years. And yes, indeed. So I started at Near in 2020 to lead the EVM development. We spun that off as Aurora. And after Aurora, I've been working on trustworthy AI, which of course is very much the same thing as the user-owned AI vision of Near AI. And ASIMOV Protocol is the latest spin-off from the last couple of years of work I've been doing. We want to specifically focus with ASIMOV Protocol on the problem of high quality trustworthy data and specifically structured data, which is I perceive it as an underserved area of the market. And also my own background is in knowledge representation and reasoning. So I started in KR&R in 2006, so 19 years now.
Nice. So I'm also very interested in trustworthy AI. I never thought of it from perspective of using knowledge graphs. So that's an interesting perspective. I was looking a lot into formal verification, which I guess more of a complementary than competing technology in this case. So I guess there are several things we can start from. One is why knowledge graphs, right? And I guess with that we can also can you give like a short overview of how you can so the whole point is for the knowledge graph to be trustworthy, right? So I remember like in the past we had some there was I wouldn't remember the name, but there was the open source version of the Google knowledge graph, right? And it had a lot of
there was a Freebase, if you remember.
There was a Freebase. Yes, there was
Google acquired MetaWeb in I think it was 2010 or something, and that's actually why we now call these things knowledge graphs, because prior to that wasn't really a popular term. When I got started in 2006, we called this semantic technology, as in part of the semantic web vision and all of this.
Yeah, right. But from my understanding is that part of the ASIMOV protocol is ensuring that the knowledge graph is correct, right? With some definition of correct. So I would be very interested to hear how you approach it in general, and if you have any metrics or benchmarks to verify how good the current knowledge graph is.
So maybe useful to introduce to people what a knowledge graph is first, because I'm sure, but I would suspect most of the audience hasn't yet heard this term. So usually, if you have a whiteboard, you would be modeling the world in terms of boxes and arrows, right? So Alex is a box, Arto is a box, or perhaps a circle, depending on style. And then we draw some kind of relationship in between them. So for example, Alex knows Arto, right? So that's a knowledge graph. It's as simple as that. So it's super intuitive. It absolutely fits how you would just, from first principles or perhaps human intuition, draw something on the whiteboard. And as it happens, it's also a really good way to just model the world. I would argue that it's the universal data model. All other data models are subsumed by knowledge graphs, meaning that anything else can be mapped into a knowledge graph. So whether you have an Excel, whether you have a relational table, whether you have a JPEG, MPEG, whatever, JSON, XML, everything can be mapped onto a knowledge graph. So it's sort of the one graph to unite and bind them. And then, of course, once you bring all of your data into this one graph, it means that everything is in interrelation to everything else in some way, even if not directly. And that means that you can achieve extremely powerful results with graph queries. You can traverse the graph, you can transform the graph. You can, once you have everything mapped to this data model, you can intersect data set at will. There's no problem about merging things. And this is one of the unique propositions of knowledge graphs. So knowledge graphs have been used in the past decades, especially in enterprise data integration. So, for example, the whole business of Palantir is built on knowledge graphs. They didn't speak about that much in the, I guess, first decade of their existence, but these days you go to the Palantir website, it's all laid out there. It's knowledge graphs, ontologies, everything is there. And in fact, I point even some of our own recruits at their documentation because it's fairly comprehensive. And Palantir, of course, has been building these knowledge graph systems for especially the three-letter agencies in America. And I think they had once upon a time some slogan like, actionable insights from bringing all of this data together. So very much that is what we want to help achieve for individuals, for all of us. So you could consider it from the Palantir angle, something like your personal intelligence agency in your pocket would be possible. Or if you consider it from the enterprise angle, are familiar with those terms, then it would be something like your personal data warehouse that your AI is accessing, your trustworthy personal AI is accessing. So I think this is a really important future to build.
Mm-hmm. Right. So how do we ensure that the knowledge graph is at least resembles some correct data?
Yeah. So just like any sort of data system, these are not really, we don't have truth in the system, right? Epistemically, that would be impossible. It's very difficult to really nail down objective truth. Even in science, the best we can do is falsifiability, right? We can't be sure that our model of the world is correct. So we don't aim for that. What the knowledge graph consists of are assertions of facts. So Aristotle defined knowledge as justified belief, which has been slightly iterated upon since then, but it's still a pretty good definition. So a knowledge graph then carries within it not only the data itself, but typically also data about data, metadata. Where did this data come from? That's provenance. Why should we believe it to be true? And so on and so on. So this means that you have some basis for why you might believe that something is true in that knowledge graph. But they are fundamentally, it consists of asserted facts. And if you want to do fact checking of a knowledge graph, which definitely we are pursuing, then that can't be done, again, epistemically. You're not aiming at objective truth. Instead, you're aiming at fact checking of this knowledge within some bounded context. And a bounded context could be, for example, Wikipedia, certainly. But I mean, Wikipedia is variable quality, right? So it could be the Encyclopedia Britannica, or it could be some other data set that's relevant to that particular thing that you want to validate. So we have a collaboration with some of the leading researchers in the world in this focus. That's the DICE research group at Paderborn University in Germany. So very interesting research from there. You can check that out.
Mm-hmm. So in some of the material online about the protocol, there's a diagram which has so some people propose new data to be included in the knowledge graph, right? And then there's a validation step. So you mentioned right now that there are some ways, like that the data has information about provenance and whatnot. But at the end of the day, is validation, is it fully automated? Is it primarily manual? Is it like semi-automated? What is the exact process of ensuring that metadata is actually valid?
Well, so very importantly, it's open-ended, right? Meaning that it's extensible, it's community contributable, and it can improve over time. But fundamentally, you want automatic validations, and you also want human validations, right? And all of this can be folded into basically annotations about the existing knowledge, the existing data. So metadata, right? I believe that in the future, it would be rather sensible that most of the data that we consume and reaches us would travel with a lot of cryptographically verified metadata about it. And in particular, of course, we really want to know where information comes from. We want to know that, at the very least, we want to know that this particular cryptographic key pair is the origin of this claim about the world, and then it has been forwarded and traveled, kind of in a peer-to-peer fashion, perhaps. But in the end, we can still see that it came from that particular public key.
Mm-hmm. Interesting. So I guess also an interesting. I don't know if you guys looking into that, but part of the problem here is that in many cases you don't want the data to be associated with you specifically, but you do want it to carry some of your expertise, right? So, like, if I'm a doctor and I want to speak up about, the importance of COVID vaccines, but the current government is conservative and that's not a popular opinion. I want my credential of being a doctor to be attached to the information, but not my name, right? So
yes,
it's
that can of course be.
I don't know if you're looking into that.
We absolutely are. So let's say I would fold that under the info finance banner, and there's many ways to achieve that. One would be, of course, some kind of a blinded scheme, perhaps zero knowledge based. Another one would be actually forget cryptography and just allow somebody to put their money where their mouth is, meaning that, let's say I'm a whistleblower. I on that unknown account, that NUM, I don't have any reputation, so nobody's going to listen to me. However, if I have the means, I could post something like a bond on a claim about the world, right? And this would be a little bit like either mini prediction market, meaning that if somebody can show that within the scope of the protocol that this is a false claim about the world, then that money is forfeit and perhaps distributed to the people who showed that. But it could also just be basically a kind of surety that this money is locked up forever. It's just there to emphasize that this is really important, right? Both models make sense in different contexts.
Yeah, the latter just happened recently, right? With someone sending 500 ether into the void.
Yes, nice. Yeah. So yes, even ad hoc, this kind of things can be done, right? It makes sense. So formalizing that as a protocol, these are directions that we are working on. But of course, first we need to build the basic infrastructure here, the data market and all the publishing and consuming mechanisms.
Yeah. So from technological perspective, I guess there are a couple of things that are interesting here. One is where is the data stored, right? Because presumably those data sets will be quite large, right? And ideally, you want them not to disappear over time, especially the valuable ones, right? So I guess also some concept of a value needs to be attached here to the data set, right? Because if someone uploads 1 petabyte of data,
Yeah. Yeah, exactly. Now on this front, I'd say that in the original semantic web vision from Tim Berners-Lee, the inventor of the web, so he was never quite satisfied with the web and he envisioned something more. And in fact, I would encourage everybody excited by agents to go and read his piece in Scientific American from 2001, where he envisioned both the semantic web and of course, the agentic web, you might call it now. So this was Tim Berners-Lee, Ora Lassila, and Jim Hendler, sort of the foundational document for, what I began working on as well in 2006, and what has inspired thousands of others in the field. In terms of, sorry, I think going on this aggression, I slightly lost the thread there. Can you remind me of your specific question?
So my question was, how do we not lose the important data, right? Like if I take a dependency as a user on the data set, I would like the data set not to disappear. I guess I can download it.
Exactly. So this first of all, we can think about how not to do it. So we have kind of seen in the last 20 years how not to do it, and that is in fact storing on the web is a fairly poor idea, just empirically. Most of these data sets that used to be part of, for example, that linked open data cloud that I showed in a previous presentation, they have disappeared over time. They are 404s now. And therefore, I think we have sufficient evidence that that's not the way to do it, right? So I actually think that this is where the connection to blockchains really makes sense. So often blockchain everything is criticized about being a solution in search of a problem, but in this case it really isn't, right? In this case, I'm a database guy. I wrote a distributed graph database in 150,000 lines of C++ in a previous startup I did. In 2010, I did my first knowledge graph startup. So if you think about the fundamental of the blockchain, well, it is a append-only immutable transaction log. So that is also the basis of modern databases. So it makes a lot of sense to treat the blockchain as though it is I call it the anchor for these data sets, right, over time. And it means that as the data sets mutate over time, you still have the possibility to go back to historical revisions by just going to previous block heights, previous block hashes, right? So in the ASIMOV protocol, indexers can make available either the current tip, the current state, materialized state of a dataset, or they can at their choice also, support the historical revisions. And as for where the data actually is stored, we have two methods. We do support on-chain data, but obviously on-chain data is only sensible economically for fairly small datasets. Mind you, Near protocol is one of the better chains in this regard in terms of the storage costs. That I'd say that even medium-sized datasets might be reasonable on Near protocol, depending on the publisher's choices and means, and what it will be utilized for. So in principle, on-chain data could be utilized from smart contracts, for example, and that gives additional utility to that data being on-chain. But we also support, of course, off-chain data. There's really no choice about that. As you said, the datasets could run into the terabytes or petabytes, and as a result, it must be supported off the chain because nobody's going to put that on the chain, not anytime soon. And in this way, if you have off-chain data, then effectively you have data dumps somewhere that the indexers will pull and load. But they are, of course, cryptographically anchored to the chain so that we can be sure that they will not change underneath us over time. But also, you don't want just a single URL of where these dumps are accessible and stored. There's a mirror list, right? And the mirror list for that dataset dump is just a list of URLs. And the URLs could be anything. They can certainly be in an S3 bucket. They can certainly be on IPFS. They can be on Arweave, Iris, or any other protocol. So long as at least one of them remains accessible over time, which of course those protocols could also work hard to guarantee, for example, in the case of IPFS, then we're good, right? We are able to pull the dump, we're able to validate that it hasn't changed, and the indexer is able to, index and materialize that into a current state suitable for query processing.
Yep. Yeah, interesting. So the problem, I guess, here is that if the dataset is massive, then the replication cost is relatively high, right? And it's hard to there's definitely quite a few interesting things to consider here. Starting with it's hard to verify that those links are actually live, right? Because, if it's an S3 bucket, the only real way to verify that it's correct is to fully download the data set, right? Which
Absolutely.
could be, 15 terabytes inside.
Yeah.
Right, and then
mind you, there's an alternative there. So one of the things we are encouraging in talks with Iris 384, which is a stealth startup in this space as well, from an ex-Google actually, and a number of others. We are encouraging them to provide primitives where there would be at least a little bit of computation possible on their side, right? Directly on the storage, right? And especially hashing. As long as we can get, if you can get the hash of that remote object on a protocol level without having to pull the whole object, well, that certainly is a good idea, right?
Yeah. There's also a possibility that two of the URLs both serve the file, but from the same underlying storage, right? So this way, there's a sense of redundancy. right? Which might not exist. But yeah, I guess it's one of the interesting questions, which is not specific to ASIMOV protocol, right? As data becomes more important, figuring out how to store it.
The largest data sets we're currently looking at in terms of making available in the initial seeding of the protocol. So we are certainly making available OpenStreetMaps. That's about 400 gigabytes in the data dumps. And we have collaborations in the bioinformatics space. I've worked with bioinformaticians for, I guess, 10 plus years now. And those are some of the very, very largest knowledge graphs in existence. So datasets like UniProt, for example, or PubChem. I know the principles for those projects. And these are just gargantuan, huge datasets. So making these available for especially the scientific community is a goal here.
Yeah, great. Then I guess the next, again, on the infrastructure side, there's quite a bit of, you mentioned you built a big graph database in the past, right? So this project also requires some sort of graph query, right? So is it, are you using one like Node4j or something similar, or is it again grassroots? No.
So in principle, indexers in the protocol could be using anything that they choose, right? They could be using any software stack they choose. But of course, we'll make available a reference implementation in coming months. The reference implementation is based on a graph database called Clever from a university in Germany. And this is a very, very capable graph database. But over time, this implementation can, of course, evolve or even be changed for something else. There's basically the graph database world divides into two tribes. There's the Neo4j tribe that you mentioned. This is usually known as the LPG tribe, Labeled Property Graphs tribe. And then there's the RDF tribe, which I come from. So this is the Resource Description Framework, otherwise Semantic Technology, Semantic Web, coming from the W3C standards in this space for the last 20 years, starting with RDF. And these databases are slightly different for slightly different use cases. So while you could store the data from ASIMOV protocol in something like Neo4j, it wouldn't really have the rich semantics that we think are important to make possible the automatic merging of datasets. So this is why this was originally called semantic technology. Well, originally, of course, this is symbolic AI, way back in the day. But the semantic part is very important if you want to merge data, right? Because if you think about, let's say, all the applications that you built ever yourself, even among the applications you built yourself, you're going to have used very likely in a career spanning decades, you're going to have used slightly different semantics, for example, for name fields, so first name, last name, maybe sometimes middle name, right? So unless there's agreement on even basic things like that, which is the realm of semantics, it's going to be harder to automatically merge datasets, right? But when the semantics have been nailed down on all of these properties, then you can just merge it. And moreover, you can merge it dynamically on the fly, right? So in query processing on the ASIMOV protocol, one of the unique value props here is that your query can intersect any data sets on the protocol, including the full closure of the whole protocol, right? And this is phenomenal because normally we access data sets, specifically, or data sources, right, through some API or something. And so one of the most important things in everything we're doing is that as we build a decentralized data market, which could also be considered a sort of trustless global graph database of all the world's information, you can just intersect any of these at query time. And as long as they have well-defined semantics, which is where ontologies come in, it all checks out.
Yep. So also in some of the demos you were showing in the past, the data is fed into LLMs, right, for processing. So is it like Is there any rocket science there? Is it just like a tool use, or do you guys have some more sophisticated integration with LLMs?
Yeah, so there's multiple phases to this. So right now we are mostly utilizing existing open models, and of course, especially the Llama models have been a focus in the last half a year. But there's also a longer term direction. So academia has been pursuing the so-called neurosymbolic synthesis for the past several years. Neuro for neural networks, and symbolic for the symbolic knowledge representation. And there is a lot of research that marries these things deeper than for example, prompt engineering, as in deeper than the zero shot approach. And I think there's a lot of promise there, which I can describe separately. But of course, in terms of the current available technology beyond academia, we are certainly building it on top of the open models, which means it's ultimately prompt engineering, right? Yeah. So, for example, we've explored in our research papers, we've explored also fine tuning, but the gains over the zero shot approach are not that significant. Mostly with fine tuning, you change the interaction patterns, not so much, for example, feed it new data.
But the interaction with the knowledge graph is similar to interaction with the RAG, right? Like at some point, model just chooses to query the protocol, or like at which point does it connect to the knowledge graph?
Sure. So there's many ways this can be achieved. Where we began from, in terms of the trustworthy personal AI, we began from knowledge capture. This meant that currently people are basically storing the whole conversation history that you have with ChatGPT or whatever, and I don't think that's a very useful or good or scalable approach because you can't fit all of that into the context window anyway. So we extract knowledge from the interactions with the user. My kind of go-to example is that because it actually kind of happened. Let's say that it's your wife's birthday. You want to tell your personal AI that, hey, order her some roses for tomorrow, right? Tomorrow is the birthday. And at that point, we can capture from this super tiny interaction, we can capture user has a wife, we don't know her name, we'll fill it in later. She's a blank node in knowledge graph terms. We know that her birthday is that particular calendar date. We don't necessarily know the year, but let's say that you say, order 20 roses, 30 roses, 40 roses, whatever. We could, of course, infer and perhaps prompt the user to confirm the birth year from that. And we know that she prefers flowers and specifically roses. And through the interflora integration, we can achieve the order, right? So that's an example of knowledge capture. So of course, all of that will be in the conversation history as well. But the conversation history is like a chat log. It's not high quality. It's not useful. You want to actually extract the useful things from it, and then basically archive the chat log, right? Does that make sense?
Yeah. Interestingly enough, from ordering 40 roses, you can immediately infer the person is not in a Russian-speaking country, because in none of those, even number of roses is an appropriate gift.
Aha. Yeah.
Thanks. Yeah, that's part of the culture, that the number of flowers must be odd.
Okay. Yeah. Interesting cultural knowledge that might go into specific things like this. But so that's one side of the utilization of knowledge, or rather, in this case, the extraction and capture of knowledge. And we publish papers on that. Now, the other side, though, of course, is the utilization of knowledge. And here there's many approaches, but the obvious one, of course, is that, like you said, replacing RAG with a more fine-grained approach, right? So RAG. Remember, RAG is often called semantic similarity, but it's not really semantic. It's just similarity. So it means that sometimes you get a rather irrelevant snippet, and also, of course, often the snippet that you wanna pack into the context is actually like mostly irrelevant. It's just that it's in paragraph form. So what you're gonna do, you kind of pack that context term. So with the knowledge graph based RAG, so of course, Microsoft Research published GraphRag, and many others have pursued this as well. We get a very, very fine-grained approach. meaning that ultimately, it may be useful to mention, knowledge graphs decimate into something called triples. So every knowledge graph in the computer is not represented as a graph typically. Instead, it's actually a set of statements or facts, so asserted facts. And this consists of subject, predicate, and object. And sometimes some more metadata about it. But fundamentally, those three things. And what it means is that you get an extremely fine-grained ability to pack the context, because you're ultimately dealing with individual statements, individual facts, instead of paragraphs of perhaps irrelevant text. So you can fit more into the context window in this way. And obviously, you have multiple ways to do that. You could render it into natural language, which is fine for a proof of concept or something, or you can make sure that the model understands a more compact syntax, and you can just fit more and with better specificity.
Yeah. So it's like I mentioned earlier today, right? The many of them support the concept of tool use, where you can specify very specific format. Like,
Yeah, there's actually one more thing that I want to mention there is that in conversations with investors over the last few weeks, it's clear that there's one particular use case that we probably ought to focus on in the beginning, and this is really enhancing agentic AI and AI assistants in terms of verified answers, right? So my go-to example I gave on stage last week in Denver. Suppose that you're a movie buff. Everybody likes movies and the Matrix especially. So suppose that you ask an agent, an assistant, a question structurally similar to, in the Matrix you had the Wachowskis directing, you had Keanu Reeves, you had Lawrence Fishburne. Which other movies did the same crew work on, right? So in principle, LLMs are well positioned to answer because they've read the web. They have this information in there somewhere. But the problem is, whatever they answer you, Alex, you won't be able to trust it, right? You'll feel like you need to double check it. And how do you double check it? Well, you go to IMDb, right, the Internet Movie Database, or perhaps somebody goes to Wikipedia or the like. So this kind of a use case is something where we can provide value, and it basically then transforms into tool use, meaning that as you identify that this kind of a question could be answered from verified knowledge, then that activates the tool use of going out on the ASIMOV protocol to shop for an answer, in a sense, literally, right? Meaning that this question gets turned into a graph query, and that graph query then accesses those high quality, verified and vetted data sources that provide a high quality answer. And in the user interface, that's rendered similar to Perplexity, but with far higher quality, as in some kind of a check mark that this is a verified answer based on verified data and citations. These data sources were used, right? So this seems like a use case that we'll probably focus on initially quite a lot.
Yeah. I think I'm not a big movie person, right? But you were showing, again, watching one of the videos, you were showing an example with books, right? And the particular query you were using, Greg Egan, right? And if I see someone mentioning Asimov and Greg Egan in two consecutive sentences, I immediately know that I want to read books that person read, right? So like an interesting use case here would be me exporting your Goodreads temporarily, right? And saying, hey, what are the books that that person ranked high on their Goodreads, which I haven't read yet, right? Please give me those, right? So that I think is a
So that's an example of a really nice graph query that can be turned into a really nice graph query that basically accesses my published Goodreads, your published Goodreads bookshelves, and yeah, it's a fairly simple thing to answer as a graph query.
Yeah, well, it's even a little more challenging, right? Because I don't have Goodreads, but I do have a text file that has all the books I've read, right? So it's which is obviously, I presume, it should be exportable.
Yes, absolutely. Just needs to
Importable, I
be.
guess, right? Importable into.
Yeah, just absolutely. Just needs to be then handled a little differently, because then the identifiers don't exist. But of course, it can be answered from free-form text as well.
Mm-hmm. Yeah. I think generally when it comes to assistance, there's a lot of structured data that is involved in our lives, and there's, I think, quite a few. We already have plenty of interesting products that are assistant-like, and most of them work in the space of language, right? So if you say something, it puts all the data in the context, and then it's a DeepSeek R1 doing some reasoning and saying this is the answer to your request. Right? So obviously in the language space, 99, I don't know about 99, 90% of the time it will do everything correctly. 10% of the time it will miss a critical part, which in the symbolic space would be, first of all, much cheaper to execute, right? And second of all, there is no opportunity.
Yeah, I actually developed a nice analogy. I think you'll appreciate. So this might go over some of the listeners' heads, but in terms of parsing theory, I think that what we as an industry are currently doing with LLMs is very similar to just having a tokenizer, just a lexer, right? Because it's text and/or tokens in and out, and where else in computer science are we really inputting plain text and outputting plain text? It doesn't make a lot of sense. So I think that clearly LLMs are a good answer to that age-old problem of how do we parse and understand language, and the structure there makes a lot of sense. But in terms of the reasoning, well, it would be good to reason on concepts instead of tokens, right? And to this effect, there's research into things like large concept models instead of large language models, where in fact the embeddings in there correspond to concepts instead of to tokens, right? And therefore, I think that hybrid systems are inevitably the future, where we have the front end of everything is the language understanding, and perhaps that's preceded by the handling of audio, as in voice, speech. But then on the back end, we must get to reasoning in concepts instead of tokens. It doesn't make a lot of sense to reason in tokens.
Yeah. So I think it was over a year ago now, but Ilya and I were discussing the neurosymbolic AI, right? And the idea was that ideally you want to do, not only you want to do it in the concepts, but also you want to do it in a symbolic way, right? Where there is no no probabilities involved ideally, right? And it's especially like at least in the places where you can do it in in the without involving probabilities. At the end of the day, I think the problem is that the incoming request inherently is in natural language, which is non-specific, right? So you have to involve at least step of conversion it into into the formal language, which will always be leaky, right? And then I think the way we were looking into it, because once it is converted into some sort of formal language, right, then you can execute it on top of graph data in like some sort of higher order logic, right? And so the way Ilya and I were thinking about it is that you start with the natural language, you convert it into this formal representation, and then what you can do is you can convert formal representation back into natural language using conversion that is not neural network based, right? And say it back to the user and say, hey, is this what you want from me, right? So this way you avoid this problem of initial conversion. But once you get into symbolic space, then it's interesting, right?
Yeah, I think that's fundamentally right as an approach. As in the analogy I meant to get to is that just like a lexer is the input for everything we do with parsing, well, the lexer is followed by a parser, right? And the parser operates on a BNF grammar, Backus-Naur form, and it forms a symbolic structured representation in memory we call the abstract syntax tree, parse tree, and then abstract syntax tree, right? So very similarly, I think that inevitably here we will evolve beyond plain text and tokens and so on, It's not that they aren't needed. They're definitely needed in terms of understanding language and handling typos and ambiguities and so on. But then that's just the front end, and that's followed then by as you said, symbolic space, one way or another.
Yeah. I think the I was thinking quite a lot about. So I think in this case, the knowledge graph, right, and some sort of formal, like higher order logic, they are quite complementary, right? And obviously, we can do quite a lot before we even get to higher order logic, right? So you have plenty of examples where you can construct a query the database, get the results, and that's already solving 90% of the problem, right? But at some point, I think marrying this technology with some sort of high order logic where we can go and do multiple steps of inference of reasoning what exactly the user wants or how to get from the data to what they want.
Well, look. So look, in my field, that's called entailment, right? So that's always been the part of the story. It's knowledge, representation, and reasoning, right? So the reasoning is automated machine reasoning, and this has existed for decades. And an example is we had the earlier knowledge graph of Alex knows Arto. Well, the knows predicate is a so-called inverse functional predicate, meaning that it implies the other way too. If you know me, I know you, right? So it means that as that first fact is added to the knowledge base, the inverse is added to automatically, right? And similarly, let's say that you have something like a family relationship that, your father is this and his father is this. Well, that implies that your grandfather is this. So this has worked great for decades, right? This exists and is a standard part of this kind of a technology stack, and this can complement the very different kind of reasoning that LLMs are able to do, right? So basically, this is an enrichment of data that happens automatically as data is inserted into the knowledge base. And by the way, last week, what I read on the plane to Denver, a fantastic new paper out of MIT by Professor Bühler, which is entirely about exactly everything we're talking about, the neurosymbolic approach to scientific discovery, automated scientific discovery. So he starts from a knowledge graph that is basically, how should I say, fairly shallow in terms of what he wants to accomplish. In his case, a very cool use case, he wants to accomplish the automated invention of new metamaterials that have strong impact resistance, right? And so by the end of the paper, the approach does come up with a rather novel metamaterial that perhaps humans wouldn't have been able to invent. But to get there, there's iterations where the knowledge graph is enriched and expanded, and just you can see the visualization just unfolding. The knowledge graph grows, connects to different domains of science and engineering, and just so I think that there's a bit of a preview of the future right there.
Fantastic. Yeah, that's like a dream application of something like ASIMOV Protocol, right?
Yes, exactly.
Yeah. Okay, we're running out of time, but in some of the discussion prior to this, you had an interesting question, which is, if we discover aliens, will they use knowledge graph? So I'm curious to hear if you think they would or they wouldn't.
Yeah. So look, the same way as binary data is we can reduce everything down to binary data, and it's a little hard to conceive how you would reduce it any less than or more than just two choices. There's a similar fundamental aspect to knowledge graphs. So it's not only that they map to our intuition very well, they map to the structure of the world very well. It's that if you just conceive of representing any information about anything, about whether it's some physical corporeal thing like a person or house, or whether it's an abstract concept, to represent two things in relation to each other, you necessarily need three things, right? You have an entity, and you have a relationship between them. So that's actually what we call a triple in knowledge representation. So that subject, predicate, object. The predicate is like a property or attribute or relationship, and you can't really reduce it further than that. So in a sense, it's really pretty fundamental, and so you can think of it as sort of it is a numeric tower that sometimes in programming languages we talk about. Similarly, there's a semantic tower, right? So it begins with uninterpreted bits that we then choose, for example, to group into segments of 8 bits. And with that interpretation, it becomes information. And of course, that has multiple levels. We can say that 8 bits is a signed integer, so that's another level of interpretation. And eventually, as we transcend the semantic tower, we get to justified belief, as in knowledge. And that's sort of the gold standard of information, as in we have given an argument why we should believe this to be true. Potentially, there's arguably there's an additional level, which would be wisdom. But I'm leaving that out of the picture right now. That's a bit subjective and hard to understand. But so I think fairly reasonably, if we discovered aliens, they ought to be familiar with binary, and they ought to be familiar with knowledge representation, which we would call knowledge graphs.
Interesting. Also, I found it interesting, completely unrelated, that in all the works of Asimov I read, there are never aliens, which is,
Yes, that's
I never thought about it before, but that's fascinating.
It is, isn't it? Yeah.
Yeah.
He wasn't a big believer in that,
Yeah.
but he was a big believer in trustworthy AI, and that's where the name choice came for us as well.
Yeah, that's what I figured, that it must be related to the 3 laws of robotics, eventually 4.
Yeah, he was not only the first AI aligner who ever lived, but he was also, of course, the very inventor of the term robotics. And his the path dependence is that all of our future imaginings about AI and robots ultimately flow through his works. He shaped how we think about this whole universe.
Yeah, it's interesting that I actually, obviously, it's very hard to live in the modern world and not know about the 3 laws of robotics. Similar to how you might never watch Star Wars, but you would know that, Darth is Luke's father, right? But I only recently read I, Robot, and I found it fascinating that the entire book is actually entirely about misalignment, not
Yes.
about alignment, right? So it's
a lot of the Asimov stories about this are almost like Agatha Christie novels about AI alignment, right? As in, we know that the robot done it, we just don't know how the hell he did it, because 3 laws of robotics.
yes, yeah, it's the entire series about a lot of aligned robots doing misaligned things. So it's very interesting in the context of alignment in 2025. To read how someone in what would it be, 1940, right, for the earliest one, right, almost 100 years ago, would think about this problem.
It's an impressive imagination. And by the way, maybe I can mention here, for those who aren't readers or aren't familiar, I, Robot by Will Smith, one of the movies based on Asimov's works most directly. The Bicentennial Man with Robin Williams, and then of course the visually spectacular Foundation series on Apple TV.
Right, and also for those who watched the Foundation series and didn't like it, it's worth mentioning that it has nothing to do with the actual book, right? So you might still enjoy the book.
For sure.
Yeah. Okay, yeah, I think we almost twice over time, which is but that was a great discussion. It's definitely in the field that I enjoy a lot.
Lovely to
Right.
talk to you.
Yeah, thanks a lot for joining us, and thanks a lot for sharing your wisdom, and looking forward to ASIMOV Protocol launching soon on mainnet, right? That's the
Q2.
Yeah, that's what we're expecting. Yeah, so, yeah, great talking, and yeah, all the best with the launch.
Thank you, Alex.
Thanks a lot.